Hello, and welcome to my oral assessment of polar graphs. So today we're going to be assessing a polar graph, or a limacon, and graphing it, plotting the points that we find, and yeah. So here's our polar graph that we are going to be graphing today. As you can see, it's going to have a loop because the 2, which is in the A, the 2 right here, which is in which is A, is a lot less than 4, which is B. And as you can see, if A is less than B, it's going to have a loop, whereas if A is equal to B, it's not going to have a loop, it's just going to have a point. And if A is greater than B, there's just no loop or point, there's just like a dent. So we're going to be graphing a limacon with a loop today in a cosine graph. So the first step to graphing this equation is plotting the points. So we're going to take all of the points, well, not all of them, but all of the main points on the unit circle right here in the place of theta from 0 to pi, because that represents both positive and negative values of cosine along the x-axis, which is what cosine is equivalent to on a regular graph. So we're going to be plotting these points in for theta. Okay, so by the process of just plugging in points for the cosine value, like for example at pi over 6, the cosine value is the square root of 3 over 2. And by just plugging that in for theta and plugging that into the calculator, I got a 5.5 as the output, and that is going to be the R point on the graph. Now the reason that we only graphed from 0 to pi is because if we had graphed from pi to 2 pi, all of that, it would have just ended up being the exact same thing reflected over the x-axis. So when I graph it, which is going to be in a minute, I'm just going to graph these points and then reflect those points over the x-axis because the points are inverse, and if I would have graphed pi and 2 pi to 2 pi, it just would have ended up being reflected anyway. So that's why I'm not doing that extra work. Alright, so this is the final product for the polar graph that we graphed, r equals 2 plus 4 cosine of theta. Basically, what I just did is I plugged in these points, like you see for 0 here, I plugged in 6 along the 0 line, and then so on for pi over 6, I plugged in 5.5, and this is not equal, this is not exact. As you can see, my circles are very messed up. But just to explain real quick how we got the inner circle, is the inner circle, these points in the inner circle are negative. And whenever you have negative points, you want to use the opposite side of the line. So it looks like I'm graphing on 0, but when I'm actually graphing from pi. So my pi value is -2, so I have this right here along the pi line at -2. And that's basically how I got the inner graph. Now, to start out, I graphed these points along here, and then I just reflected the rest of the points over the x-axis. If we were working with sine, we would reflect over the y-axis because, as we know, sine is in the y-axis. If it's like x, y, it's cosine, sine. So we reflected over the x-axis for cosine because the cosine is equivalent to x in this graph. And yeah, this is basically our polar graph for r equals 2 plus 4 over cosine of theta. Thank you so much.